Okay, this is IGCSE Physics 0625/42, paper for October, November 2021, questions 5 and 8. Okay, so we have a thermocouple thermometer. It's used to determine the temperature between a mixture of ice and water and liquid mercury at approximately 600. So this is liquid mercury at 600, and this is ice and water. So complete figure 5.1 with a label diagram to show how the thermocouple thermometer can be used in this way. You guys know that a thermocouple has two junctions, the cold junction and the hot junction. Okay, so in this case, obviously our cold junction, I'm gonna use red actually, or blue. Our cold junction will be over here, right? It should be in. It should be inside of it. How is it gonna measure it if it's not in? Okay, and you have the hot junction over here. Okay, we know that they're connected to a galvanometer, right? So we can put it like this, and the galvanometer looks like this with an arrow on it. You should know that these junctions are also connected. So obviously, and I'm just using this just so you can kind of visualize it better. I'm using two different colors. In the exam, you're going to be using pencil. Okay. But why I'm using this is because we said label, right? So this is obviously galvanometer, right? This is your first mark. Okay. The second mark is the junctions being inside the liquid. If you don't put that, you're going to lose a mark. So that's one more mark. And it's 3 marks. What the third mark is, remember, in a thermocouple, you need to have two different wires, right? These blue wires will both be made out of the same material. So you could maybe put, like, I don't know, an arrow like this, okay? Or I don't know, this is very bad. And you can say this is iron wire. And then over here, you can put an arrow and put copper wire. Okay? So, excuse my drawing, actually. Don't do it like this. Hold up. Don't put it like this. Put iron wire, and then over here, let me just close this. And then put also here iron wire. And then over here put copper wire. Okay? It doesn't have to be iron. It can be any metal, any two different metals. Okay? As long as these two are the same and this one is different. Okay? So, that's the first one. Okay, then they said state two other physical properties that can be used to measure temperature. Okay? Uh the properties we use to measure temperatures, here they talked about they can be used. It measures the difference between two solutions, right? What are other physical properties we can use? We always look at expansion. Remember, in the bimetallic strip, we look at the expansion of solids, and also in an in-glass thermometer, what do we look at? In the thermometer, we look at the level of the liquid. It rises and goes down according to the temperature. So that also shows that there's also what expansion of liquids. Okay. State two benefits of using a thermocouple instead of a liquid in glass thermometer. Thermocouple. Thermocouple is there. It has many benefits, such as low heat capacity, sensitive to fluctuations in temperature, so it responds quickly to changes in temperature, and it has a wide range of temperatures. So the first thing I'm going to say is wide range of temperatures. Okay, and the second one I'm going to put is, let's say, can reach high temps. Let's take a look at the marking scheme. Large range and measures high temperature. You can say any of these. It has a small size, small thermal capacity, suitable for whatever, responds quickly. This sensitive. This basically means it's sensitive. Okay. Um, we have also question 8, right? Final question 8. Over here. Okay. Oh, we've seen this before. Figure 8.1 shows a conducting object A initially uncharged held on an insulating stand. The positively charged rod B is brought close to A. What happens? How do the charges look now? Okay, obviously there's going to be an induced negative charge on this side of the of this, I don't know, let's say on object A, right? Because these positive charges would attract negative charges. Okay, so we're going to draw the negative charges closer to the left. And what's important is that you also draw positive charges. And what's important is that there is an equal number of positive and negative charges. Okay, make sure they're equal. So here I have 6, here I have 6. But let me add a bit more. So I'll add 3 more over here. So I have 9 on each side. Okay, A wire now is connected from object A to Earth. State and explain any movement of charge. The answer is electrons, or you could say negative charges, whatever, will flow to A. And the explanation is they flow to balance the excess positive charge. Some people are going to say, "Tab, how?" Okay, when you connect a wire and connect it to Earth and you ground it, electrons are going to leak out. Basically meaning what's going to happen now, the object's going to be positively charged. So what's going to happen after that? Electrons are going to have to flow back to A to balance the excess positive charge. Okay, so you can take a look at the marking scheme over here. And negative charges will flow to the object. Okay, why? They flow to balance the excess positive charge. Okay, there is a current in a wire of 0.65 milliamp for 2.2 minutes. Calculate the charge that flows. Q is equal to I over T. Okay, that means the current in this case is 0.65, but in milliamperes. So you have to multiply by 10 to the negative 3. 10, yeah, 10 to the minus 3. Okay, and the time in this case is 2.2 minutes, which you must multiply by 60 to make it in seconds. Okay, and if you do this on the calculator, let's see, 0.65 times 10 to the minus 3 over 2.2 times 60. You get, whoa. Sorry. Uh, I is equal to QT. Apologies. Q is equal to IT. I was thinking of the formula I is equal to the charge over time. I mixed up between these two. Okay, Q is equal to IT. Okay, so sorry, it should be the current 0.65 times 10 to the negative 3 times 2.2 times 60. Okay, and now when you put this on a calculator, times 2.2 times 60, you get 0.0858. So equals 0.0858. How do they put it in the marking scheme? 0.086. Okay. Sheklo, they want you to put it to two significant figures. Since in the question it's 2SF, so it's going to be 0.086 to 2SF. Okay, so 0.086. And you need to put the unit, right? So Coulomb. See, 0.086 C. Okay. That's it for question 5 and 8. Thank you so much for watching and good luck in your exam.